Today we will learn array of data structure. Today our topic is triangular matrix. So what is triangular matrix? In the mathematical discipline of linear algebra, a triangular matrix is a special kind of square matrix. So what is square matrix? In mathematics, a square matrix is a matrix with the same number of rows and columns. An n by n matrix is known as a square matrix. Triangular matrix are of two types, lower triangular matrix and upper triangular matrix. So, what is the definition of lower triangular matrix? A lower triangular matrix is a square matrix in which all entries above the main diagonal are 0. So, this is main diagonal. Above the main diagonal, all entries are 0. Only non-zero entries are found below the main diagonal in the lower triangle. So, lower triangle is this. So, this is an example of lower triangular matrix. All entries above the main diagonal are 0 and lower triangle elements are non-zero. In lower triangular matrix with n rows, the maximum number of non-zero elements in row I will be I. So, if the row number is 1, total number of non-zero element is 1. If row number is 2, total number of non-zero elements are 2. If row number is 3, total number of non-zero elements are 3. So, the total number of non-zero elements in a lower triangular matrix will be first row it is 1, second row it is 2, third row it is 3. In this way, if there are n number of rows, then it is n into n plus 1 by 2. Now, I want to store only the non-zero element to a linear array to save space of memory. So, for large n, it will be better to save the space taken by the zero entries in the upper triangle. Hence, we store only the other entries of the lower triangular matrix in a linear array B. I am taking one linear array B and I want to store only the non-zero elements to that linear array. Means what? Means B1 equals to A11. First, our linear array is B. So, B1 equals to A11. Then, B2 equals to A21. Actually, I want to store non-zero elements of this square matrix. Then B3 equals to A22. Then B4 equals to A31. B5 equals to A32 in this way. So, the general term is BL equals to AJK. How we can calculate this L? Now see, row number is J. Before jth row, how many number of elements are there? It is 1 plus 2 plus 3. In this way, it is j minus 1, that is j into j minus 1 by 2 plus total number of column plus k. So, L equals to j into j minus 1 by 2 plus k. Take one example, then this will be more clear for you. For A31, before third row, how many number of elements? See, before third row, there are 3 elements, A11, A21 and A22. So, it is 3 into 3 minus 1 by 2, that is 3, plus total number of column. Here the column number is 1, plus 1 means here. So, it is 4. See, A31 is stored in location 4 in case of linear array B. In this way, you can easily calculate the position in a linear array. Reprogram to store only non-zero entries of the lower triangular matrix in a linear array and then print that linear array and calculate a particular element's position of lower triangular matrix in linear array. Now see the program. So this is our program. There are two integer arrays. One is two-dimensional, another is one-dimensional. Two-dimensional array is used for storing the square matrix and one-dimensional array is used for storing the non-zero elements. Now take the order of the square matrix from the user, say it is n. Then take the elements of lower triangular matrix. Because it is two-dimensional array, I have to use two for loops, one for row, another for column. Now I want to print the lower triangular matrix. Again I am using two for loops, one for row, another for column, and I print the whole array. Now I have to check and store the non-zero element to one-dimensional array. Here I am using 2 for loops and I am checking whether it is non-zero element or not. If it is non-zero element, then store it to a one-dimensional array, that is P. See the index of B, it is L. I initialize L as 0. So index of B, that is L, and I initialize L as 0, and when I get any non-zero element, I just increase L. In this way, I just store all non-zero element of that lower triangular matrix to the array B. Now I want to print the linear array. So total number of non-zero elements are n into n plus 1 by 2, that is n1. I print n1 and then I want to print the linear array. So how many number of elements are there in linear array? It is total number of non-zero elements. Okay. So I equals to 0, I start one for loop, I equals to 0, I less than n1, I plus plus and print the array. Now the calculation. Now take the row and column value of non-zero element whose position you want to calculate in linear array. So it is j and k, and we already discussed about this calculation, and then print the value of L and I get the position of that non-zero element in linear array. So when I run our program, supply the order of square matrix, say it is 3. Supply the lower triangular matrix, it is 1, 0, 0, then 4, 5, 0, then 7, 8, 9. So our lower triangular matrix is this. Total number of non-zero elements are 6, and after storing it to the linear array, after storing non-zero values to the linear array is this. Now supply the position of row and column of non-zero element. Say what is the position of 5? It is second row and second column. So it is 2 and 2. So in case of linear array, the position of 5 is 1, 2, 3. See here it is 3. Now upper triangular matrix. The upper triangular matrix has all the elements below the main diagonal as 0. So this is our main diagonal, and below the main diagonal all elements are 0. So first row contains 4 non-zero elements, second row 3 non-zero elements, third row 2, and so on. So if I want to store only non-zero elements to a linear array B, then B1 equals to A11, B2 equals to A12, B3 equals to A22, B4 equals to A13 in this way, where BL equals to AJK. So here L equals to K into K minus 1 by 2 plus J. Take one example, then this will be more clear for you. For A23, so what is the value of J? It is 2. What is the value of K? It is 3. Now I want to store this element to the linear array B. Then what is the value of L? It is L equals to 3 into 3 minus 1 by 2 plus 2, that is 5. So A23 is stored in location 5. So see here B5 equals to A23. Tridiagonal matrix. In this matrix, all elements other than those on the major diagonal and on the diagonals immediately above and below are 0. So this is our major diagonals, and the diagonals immediately above and below are these. And except these three diagonals, these elements are 0. So this is an example of tridiagonal matrix. Now see, if the order of the matrix is n, then n elements are there on the diagonal, and n minus 1 elements are above and n minus 1 elements are below the diagonal. So total number of non-zero elements are 3n minus 2. Now if we want to store these non-zero elements to a linear array, then how we can store? We can store in this way: B1 equals to A11, B2 equals to A12, B3 equals to A21, and so on. Therefore, there 3 into j minus 2 plus 2 elements are above ajk, and k minus j minus 2 elements to the left and including ajk. So what is L? L equals to 3 into j minus 2 plus 2 plus k minus j minus 2. So it is 2j plus k minus 2. Take one example, then this will be more clear. For A21, what is the location of these elements in our linear array B? So it is L equals to 2j plus k minus 2. J is 2. So it is 2 into 2 plus 1 minus 2, that is 3. See, A21 is in location 3 in our linear array. So this is your programming assignment. Write a C program to store only non-zero entries of the lower triangular matrix in a linear array, and then print that linear array and calculate a particular element's position of lower triangular matrix in linear array. In the same way, do the same program for upper triangular matrix and also for tridiagonal matrix. This is your array theory assignment on triangular matrix. Try to answer this question in our comment section. I am waiting for your reply. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.